So last class that I did mention the 30, 60, 90, and 45, 45, 90, right? We're gonna have that quiz next week. Right. Show you. If you remind me on Monday, I'll show you exactly. So 30, 60, 90, 45, 45, 90. If you know that stuff, it's just gonna make your life so much easier. We're going to be dealing a lot with radicals, so we need to be confident with radicals. We got to be confident in simplifying radicals. We need to be confident in dealing with situations where we have a radical in the denominator. I'm going to show you a couple hacks that are going to make both of these things a little easier for you, especially this bottom one. If you can learn this, this is going to make things way easier for you. So, but let's start with the top. Do you guys feel pretty good about simplifying radicals? Like, can you do these relatively quickly? Now, in Algebra 1, we teach this with factor trees. You guys know what a factor tree looks like? Like if I had 40, I would say like 40 can be made by doing 4 times 10, and 4 is 2 times 2, and 10 is 2 times 5. And we do this prime factorization. That's too slow. We can't be sitting down making factor trees for these things. Okay. So if that's your go-to, then pay attention. Let me give you another option. What I really want you to be able to do is to look at a number like 40 and recognize that there are some perfect squares inside of 40. Give me a number that you can multiply equal 40 that's a perfect square. 4. The square root of 40 is the square root of 4 times the square root of 10. Agreed? So if you think about splitting it up into 2 separate radicals, then this makes this pretty easy, because what is the square root of 4? So 2 radical 10 would be our simplified version. Now, before I go on, I would look at 10 and say, is there a perfect square that goes into 10 other than 1? No. All right. So using the same idea for the second one here, I got 2 radical 45. I'm thinking about that radical 45. What goes into that? 9. 9 is a perfect square. 9 goes into that. So I'll think of 45 as 9 times 5. And that's great, because I know what the square root of 9 is. It's 3. And then my final answer comes out to 6 radical 5. The idea? Now what happens when you get a big old number like this? Like, I don't know. Well, that's where I reach for my trusty friend here. And I'll just start trying some stuff. Give me a guess. What perfect square do you think might go into 486? 4. Nope, 4 doesn't work. 9. 9 works. Okay, so 81 doesn't work. I'm going to go with the 9 because I want to show you can sometimes do this in multiple steps. So I could think of this as, it is 9 times 54. So that's square root 9 times square root 54. And I do know what the square root of 9 is. But I can think of another perfect square that goes into 54, right? 9 goes into 54 also, doesn't it? So the square root of 9 becomes 3. And 54 I'm going to write as 9 times 6. And can you think of a perfect square that goes into 6? No. So what do I got? 3 times 3 times root 6. That's 96. Can you guys tackle these next 3 for me? However you want to do them is fine, but I need you to be able to do them. I need you to be able to do them by hand. I know some of your calculators will actually do this for you, but you need to be able to do this without relying on the calculator too. Mhm. All right, we getting close. So this is something you're going to get lots of practice with this. Hopefully it'll become something that's just like second nature to you, you can do really quickly. But I do expect, if as we're working through these problems, if I'm asking for exact answers and you do come up with a radical, I need you to be able to simplify the radical. So you need to always be checking to see if I can simplify it. The other piece, and hopefully you learned this last year in Algebra 2, is that in higher level math, we do not like having radicals in the denominator of a fraction. And they probably taught you some method where you multiply by a fancy version of 1 last year. Is that how you dealt with it? Wait, I got something even better than that. Okay, this is going to blow your mind if you haven't seen this already. It's change your life, makes things so much easier. This is the big thing for today. Okay, you don't want to miss this. You guys ready? Yeah. Okay, it turns out that you can multiply by if you're dividing by some radical, that is the same as multiplying by that radical divided by the thing inside of it. Okay, here's what I mean. If I go 1 divided by the square root of 2, okay, that is the same as 1 times the square root of 2 over 2. Same exact answer. I shouldn't have cleared in between, but the same exact answer, and it always will be. Okay, so this is how you use this to your advantage. You're going to run into a problem where you're going to have 3 over radical 2, and you're going to say, oh, division by radical 2. That's the same thing as taking that 3 and multiplying it by radical 2 over 2. And that's it. That's my answer. That's 3 radical 2 over 2. So this radical 2 on the bottom becomes 3 times radical 2 over 2. So my final answer for this would be 3 radical 2 over 2. That's it. All right. Check this one out. I got 4 over radical 5. I'm going to keep the 4. And instead of dividing by radical 5, I'm going to multiply it by radical 5 over 5. And that's my answer, 4 radical 5 over 5. So whatever you have in the bottom, basically you move it to the top and you take the inside and put it in the bottom. That's another way to think about it. All right. Now sometimes you have to do a little fraction reducing after the fact. So this one here, same idea. We got a root 2 in the bottom and a 2 in the top. So I'll leave that 2 that I have in the top, but instead of dividing by root 2, I'm going to multiply by root 2 over 2. But we wouldn't leave that as our final answer, would we? We would cancel this 2 and this 2, and our final answer would be just root 2. What do you guys think? Have you seen this before? Anybody seen this before? Oh, good. A couple people have. Should we do a couple more, or you feel like you got it? Give it a shot on the next one. I'm going to work through it too up here. Let's see if you can tackle on your own. Probably simplify this. And whatever, 30 over 18 is about to multiply 6. It's 5 over 3. Root 18 would be 9 times 2. So that's 5 times 3 radical 2 over 3. Those cancel. That last one was a little tricky. I had a couple things we needed to do to simplify that. Do you guys love this or what? Isn't this awesome? Isn't it awesome? Yeah. It's going to make your life so much easier. Because we're going to be writing so many fractions that have radicals in the bottom. And I am going to expect you to rationalize. And there is that whole process where you multiply the top and the bottom by the same radical, and that cancels the bottom. But this is just easier to me. It's like one step instead of two. So it's the same idea. It's a little bit of a shortcut. But this is mathematical facts. The square root of any number is equal to the square root of that number divided by just the number. That's mathematical. So this isn't really like hand waving magic. It's just a little bit simpler process. All right, you ready? Ready for the next step in trig? Did you guys learn about secant and cosecant and cotangent last year? Oh, cool. Wow, this is like just total review day for you guys. All right. Let's do this. SOHCAHTOA. So SOHCAHTOA, those are our 3 primary trig functions, and then we call these the reciprocal trig functions. You guys remember why we call them that? Because they're just the reciprocal of the other ones. So sine, you know, is opposite over hypotenuse. Let's go ahead and write this down. And cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Why are they what? Not in order? They are in order. I don't know why. That's a great question. Actually, one of my students looked that up and explained it to me once, but I can't remember. It would seem like sine and secant would match up and cosine and cosecant would match up, but that's not how it is, unfortunately, which is kind of weird. Sine matches up with cosecant. So sine is opposite over hypotenuse. The reciprocal of that would be hypotenuse over opposite. Secant is the reciprocal of cosine, so hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so adjacent over opposite. So we're just going to burn through a couple examples here. We'll definitely have time for one. I'm hoping both. You'll have a section of your homework that's gonna look a bit like this. So, oh, this looks fun, doesn't it? Look at all those radian measures in there. Woo! All right. Eventually, you're gonna have these memorized. Woo. Anybody started on that yet? No. Okay. Sorry. It's all right. Hey, pi over 3. Can someone tell me what that is in degrees? That's 1/3 of the way around a half circle. 60 degrees, agreed? Okay. So I'm gonna think of 60 degrees. When I see pi over 3, I think of 60 degrees. Could you guys draw me a right triangle that has a 60-degree angle in it, please? I'm going to draw a line with a 60-degree up on the top. And then 90-degree here, and then we know what this other one would be, wouldn't we? 30, 60, 90 triangle. Oh, what a great opportunity for us to practice. Do you know 3 numbers that you could put onto that 30, 60, 90 triangle? You should know 2 sets of them. You should be working on it anyways. What's the simple one that doesn't have any fractions? 1, 2, root 3. Do you know where they go? The 1 and the 2 and the root 3? Well, the 2 is the longest, so that must be the hypotenuse, right? And then the 1 is across from the 30, and the root 3 is across from the 60. All right, you guys ready? All right, we're going to do the sine of pi over 3. Sine is opposite over hypotenuse. So from the 60 here, what would my fraction be? Opposite over hypotenuse is root 3 over 2. What's the cosine of 60? Cosine is adjacent over hypotenuse. Adjacent over hypotenuse would be 1 over 2. And the tangent of 60, opposite over adjacent, would be root 3 over 1. And again, I probably should have done this. I probably should have labeled my sides. For those of us who are still kind of on wobbly legs with this whole right triangle trig thing, make sure you label your sides. Until you're feeling really confident with it, label your sides. If you're there already and you don't need to do it, that's great. All right, tangent is opposite over adjacent. That's radical 3 over 1, or just plain old root 3. Cool. And then, do I have these in the right order so that they match up? Cool, then we could just flip our fractions. So instead of root 3 over 2, it's 2 over root 3. We can't leave that root 3 on the bottom. But it's all good because we know a little trick to deal with that, don't we? We'll leave the 2 there. Instead of dividing by root 3, what are we going to do? We'll multiply by root 3 over 3. One over 2, flip it over, we get 2 over 1, that's 2. Root 3 over 1 becomes 1 over root 3. And we can't leave that down there, but that's all right. The 1 is going to stay. Instead of dividing by root 3, we'll multiply by root 3 over 3. So we get root 3 over 3 for our final answer there. Awesome. All right, I need you to grab your calculators. Part of your homework, you're going to literally be typing stuff in your calculator and hitting enter. Okay, that's it. You got to know how to do it, right? So let's make sure we know how to do it. This is asking us to verify the sine and the secant. So sine pi over 3. Now we've already converted that to 60 degrees, so we're feeling pretty confident about that, right? So rather than switch over into radian mode, why don't we just type this into our calculator as sine of 60, right? We're already in the root, or pi over 3 is 60. Go ahead and type sine 60 in your calculator, get a decimal answer, okay? Leave it on your screen, and then type root 3 over 2 in your calculator, and just double check, verify that you are getting the same decimal answer. Did it work? Awesome. So check that one off. And what's that? Math bracket. Oh, I like what you're saying. Let's try it. Sine 60 math bracket. The problem is this is not a rational number. MathFrac's only going to work with rational numbers. So remember, radicals, if they can't be simplified, are irrational. Which means that's the definition of irrational, is it cannot be turned into a fraction. That was a wonderful question. Thank you for asking. All right, let's also verify secant. I don't need to type this in the calculator, that's 2. But how am I going to type the secant of 60 into my calculator? Anybody find the secant button yet? Second, no, that's inverse sine. Good guess. That's the key. Say it again. I'm not going to type secant in. I'm just going to type 1 divided by sine of 60. Right? Because that's what secant is. It's the reciprocal of sine. So there is no secant button on my calculator, but I know that sine and, oops, is it sine though? Yeah, I almost screwed that up. I know that secant and cosine are reciprocals, right? So there's no secant button, but secant is the reciprocal of this, or 1 over it. So 1 divided by cosine 60 is how I would type in secant. So in your math homework, when they ask you to type a secant or a cosecant or a cotangent into your calculator and get a decimal answer, you know what you're going to do, right? You're going to do 1 over whatever its buddy is, its reciprocal buddy. And that does come out to 2, so we check that one off too. Okay, sweet. How are we going to do this last one? Didn't give us enough sides. No, I mean, we have some of them. I can do, let's see, let's do the ones we can. We got hypotenuse and adjacent. I have an opposite. So I could do cosine. Cosine is adjacent to hypotenuse. 8 over 12. We'll simplify that and call that. What do we want to call that? 3/4. Divide by 4, divide by 4. 2/3. Now, hey, I got an idea here. Does anybody want to predict what my idea is? I got an idea for something that can make our lives a little bit easier going forward with the rest of this problem. Anybody want to guess? I'm going to end up just making a whole bunch of fractions out of these sides, right? Yeah. What if I simplified the triangle now, and then I wouldn't have to worry about simplifying all my fractions when I did it later? What do you guys think about that? Yeah. That's thinking ahead, huh? Because this triangle and this angle, that's going to hold, well, it's for any similar shaped triangle. Right? Remember similarity from geometry? If I make this triangle smaller by, say, a factor of 4, it's still going to have the exact same shape. The angles are all still going to be the same. So the sines and the cosines and the tangents aren't going to change. So I could save myself a whole bunch of trouble by just looking at this 12 and 8 and saying, man, I could divide both of those by 4, make this a 3 and a 2. Now when I go to do my cosine, it's adjacent over hypotenuse. Look, we got 3 over 2. I didn't have to do any thinking to simplify that. What do you think of that? Pretty good? And this, of course, is 3 over 2. All right, so how are we going to figure out this other side? There's a really famous Greek guy. Long time ago. That's the guy. You remember that guy? And it wasn't even him really that came up. I'll just student / cult follower. The Pythagoreans were it wasn't a cult, it was a religious mathematical cult. They were just some interesting stuff. All right, let's do this. X squared plus 2 squared equals 3 squared. Hey, cool. Radicals. Off the screen. My bad. I'm just doing a little Pythagorean work here. And now we've got everything we need to wrap it up here. Did I forget to swear something? Oh, yeah, I'm sorry. Very sloppy. All right, we're coming up with root 5. Nice. All right, sine opposite of our hypotenuse. Tangents opposite over adjacent. I kind of felt like I put your homework assignment on the back side of this. Did I do that? How you guys feeling? We did a lot today. Covered a lot of ground. Right triangle trig, a whole bunch of radical stuff. And then our sine, secants, and cosecants, and cosine, tangents, cotangents. All right, this is section 4.2, but this is just the first half of it. I'll see you guys again on Monday. It'll be a lighter note session on Monday. I'll give you the other half of the 4.2 homework. Does not appear as though I have time to check your homework from Tuesday, so hang on to that. Bring it back on Monday. Definitely have time to do it then. All right, you guys are awesome. Let me know if you need to schedule time with me to work on this stuff.